All right, Algebra 1A, and welcome to Lesson 2.7. Today, find square roots and compare real numbers. On the square roots, we got a few things going on here. I'm going to draw you one. This is the square root. Square root sign, we have that there. We're going to have a number inside. We'll just put the letter A, and that's what it looks like. In the calculator, if you're not sure, it is, if you see where I'm pointing on the calculator, it's this little square root button. You're going to hit second x squared to get the button in your calculator. So second x squared gives you that square root. Radicand, okay? So what we have here is, this is the radical sign. That's just our sign. The number inside is known as the radicand. So this A is the radicand. So if you hear me talking about that, that's what it is. A perfect square is a number multiplied by itself. Multiplied by itself. Okay, so something like 4 times 4 would be a perfect square, and it equals 16. An irrational number is a non-terminating decimal. Non-terminating, also non-repeating decimal. And it is not a perfect square, or not a square root. Not a perfect square root, I should say. And a real number, really those are any numbers we have been talking about today. So real numbers, often denoted by this sign here. That's the real number sign. And it's any number in existence, really. Anything at all. So really everything we've talked about up to this point is a real number. Decimals, fractions, anything except for imaginary numbers, which we're not going to talk about in this course. Anyway, so let's get into finding square roots. So if b squared is equal to a, okay, then we call a the square root of b. What I mean by that, okay, so 5 squared is 25, and negative 5 squared is 25. So 5 and negative 5 are square roots of 25. Always a positive, always a negative. So that is another little bit to add in. Always plus and minus. Okay, let's practice finding square roots. So finding square roots. All positives, real numbers, have 2 square roots, positive and negatives. That's what I just talked about. They're always together. I would highlight this, memorize this if you need to. If we need to find this in the calculator, well, let's just use our calculator. Negative square root 36. Okay, so the negative square root of 36, simply put, is negative 6. You can use your calculator. Negative square root of 36 is negative 6. Square root of 16. Square root 16 is 4. Okay, so that's the positive version. Now, you can see this sign. That just means put both positive and negative. Square root 64 is equal to 8. So plus or minus 8. So positive 8 and negative 8. Okay? You only need to include those signs if it asks you. Evaluate the expressions. Square root of 100. Second square root, 100, is 10. If you want to put plus or minus, that's fine. Negative, just the negative version. Okay, so square root of 1. This is a trickier one. Square root of 1 is just 1, and it's just negative 1. So 1 is the square root. If you're not sure of all the square roots, you can use the table in the calculator to find those, but I'll just let you use our technique so far. Okay, now classify numbers. So here's where irrational comes into play. Basically, if you don't get a perfect square, it's irrational. What I mean by that? First off, these are all real numbers. Everything we're talking about is a real number. Rational numbers. These terminate or repeat. Irrational numbers, no repeats, and do not terminate. Integers, remember those are non-decimals. They can be positive or negative. And whole numbers, they are no decimals, only positive. Okay, so classifying these numbers. Square root of 144. Well, let's see. Square root of 144 comes out to be a regular 12. 12 is a real number. They all are. It is rational. Since it's rational, it is not irrational. You can only be one of those. It is an integer because it's not a decimal, and it is a whole number because it's not negative. Square root of negative or of 49, that's negative. So square root with the negative of 49, it's a real number. It is rational. It is not irrational. It is an integer. It is not a whole number because it is negative. Square root of 32. It is 5.656, so forth. Okay, notice there's no repeating, and if this happens, you are not looking at a rational number. You are just looking at an irrational number, and then it cannot be anything else. So if you have a number like square root of 32, it can only be rational, or it can only be irrational, and that is it, and a real number. Okay? So that's the idea with those. Graphing numbers. This should be relatively simple, but I would recommend always put them in decimal form to get an idea. So square root of 16, I know is really 4. We did that in the past. 5 halves. Let's see what that is as a decimal. 5 halves is 2.5. Square root of 4 is 2. And negative 3, and the negative square root of 6 is approximately negative 2.45, we can say. I'm not looking for it to be perfect, but you want to put these numbers on the number line. So 4 would be about here. Okay, I'll use different colors. 2.5. 2.5 is about here. 2 is right below it. Negative 3 and negative 2.45. Negative 2, there's negative 3, so a little less than half. Again, it doesn't have to be perfect. Reading these numbers from left to right. So negative 3 is the least. Negative 2.45, which was really negative square root of 6. Then we had square root of 4, which was 2. Then we had 5 halves. And then we had square root of 16. So that is their order from left to right. Okay. These last little bits here, so complete the following exercises. Tell whether each is a real number, rational number, or irrational. Well, we have to graph them anyway. So square root of 49, let's check it out. It's just 7. 7 is a whole number. It is also an integer. It's rational, and it's real. And 7 is about here on the number line. 0, it is a whole number. It's an integer, it's rational, and it's real. And 0 on our number line. -6/4. It is -1.5. Not a whole number, not an integer, so it is rational and real. And on the number line, -1.5 is about here. That's -6/4. -2. It is an integer. It is rational and real. About there. And square root of 17. Let's see what that is as a decimal. It's about 4.123, so forth. So, not repeating, it's a long decimal. It's irrational and real. And it is about there or so. Okay, so take a look at that. Good stuff, guys. 2.7 is the homework. Check it out. Make sure the odds and any adjustments will be in the assignment. Good stuff, guys.